Dear participant, I welcome you all in the 10th day of this countrywide classroom teaching program 2022, and today we have deliberation on surface tension, which is delivered by the Miss Vaishnavi Pethkar madam. She is from the Department of Physics, NSB College, Nanded. Madam, session is over to you.
Today we are discussing with the surface tension. Let's introduce myself. Myself Vaishnavi Ashok Pethkar. I am from Nanded, NSB College. ला मी assistant professor म्हणून सध्या जॉब करते. Then firstly we studied about surface tension in 11th, 12th and BSc first year also. That point is mostly we are seen in the nature also, the drops molecules and capillary action in the trees, all this in the because of the surface tension. So that we have selected this topic. It is most important, so that, and the contents are the history. First of all, we started with history of surface tension. Then adhesive means the intermolecular forces between the molecules, so that we have these adhesive and cohesive forces, and then the range of molecular forces, sphere of influence, and the definition of the surface tension and details of these, and the angle of contact and factor of affecting the angle of contact. These all things we have in this PPT. Okay. Next, this history. The Agnella Lucy Wilhelmine Pockels. She is discovered firstly the surface tension and all the properties of this surface tension. She is studied in German, so that in German she established her own she established her own own points, which is Pockels points. Okay, and she have the surface science. Okay. The fundamental in establish the modern disciplines known as surface science, which is describe the property of liquid and solid surfaces and interface. Okay, the Pockels becomes interested in a fundamental research in the surface science through the observation of soaps and soapy water in her own home. While washing the dishes, she devised a surface field balance technique to study the behavior of molecules such as the soap, and the surface tensions are the inner area air and liquid interface. From these studies, the Pockels defined the Pockels point, which is minimum area that single molecules can occupy in a monomolecular films, because she was self-wrought. Pockels was audited, and she has not paid professional scientist, and she has no institutional affiliations, and so is example of citizen scientist. She's work as a citizen scientist because in the German had no access to universities. The women are restricted there, so that she is as a scientist, as a citizen scientist. But her younger brother is always try to encourage her to establish all these things, and the establish her professional life in the as a scientist. It is a history of the surface tensions. Then we go to the surface tension, but we already known about the intermolecular forces and the angle of contact, all these things. So that I will take here first slide for the intermolecular forces. Which are the intermolecular forces are observed or the cause of the surface tensions. The matter is made up of molecules. Any two molecules attract each of forces between the molecules is called as intermolecular forces. Take 1 minute. There are the two types of intermolecular forces, which is the first one. First one, the adhesive force. The molecular force attraction between the molecules which are different substance, then we call as adhesive force. The adhesive force have example, the attraction between glass and water molecules. So we here we apply the here we seen the adhesive force of molecules. Then the molecular force attraction between the molecules which are same in substance is called as cohesive force. The cohesive force are strong in solid because the same substance, correct, same substance, same molecules are attracted each other, then we call as cohesive force there. So that the solid in solid we have strongest cohesive force, and in a weakest in a gases have weakest cohesive force, so that the gas have no shape and size, and because of the cohesive force we have solids have specific shape. Then we have the next slide for the examples of the adhesive and cohesive nature, or the adhesive and cohesive forces. The first one we show that the here point this take a circle. Okay. Here we shown that the first slide, first photograph, that the water molecules are attracted the glass molecules, which is the different substance, which are the glass is a different and the water molecules are the different, so that here we called as the adhesive force. Okay. And when the water molecules and another water molecules have attractive natures, then we call as the cohesive force. Here we have the cohesive adhesive force, so that the adhesive force are we seen in the pen on the paper, then the water on the cloths, and marker on the board. But when we wrote on the glass, the more cohesive force we apply here, so that we add the HF, hydrofluorous, which add in the ink of or the marker, so that we get the we wrote on the glass. Here we ही जी स्लाइड आहे ते मला दिसते, तिथे काय केलेलं आहे की ग्लास वरती मार्कर पेननी लिहिण्याचा प्रयत्न केलेला आहे. ओके. नेक्स्ट, the range of molecular forces. The minimum maximum distance from the molecule up to which the molecular force is effective is called as range of molecular force. The intermolecular force are effective up to distance which is a few nanometers in a solid and liquid. Therefore, the short range force here the molecular range of molecular force is a short range force. Then the sphere of influence. Here we seen the sphere of influence, an imaginary sphere with a molecule at its center and a radius equal to the molecular range is called as sphere of influence. The influence or the intermolecular force is effective only within the sphere of influence. Here we seen the one photograph. There the range of influence are occur. जिथपर्यंत त्याची रेंज आहे तिथपर्यंतच फक्त मॉलिक्युल्स तो अट्रॅक्ट करू शकतो. मीन्स हा जो रेड मॉलिक्युल्स आहे तो त्याच्या स्पियर ऑफ इन्फ्लुएन्स अप टू इमॅजिनरी पॉइंट्स, इमॅजिनरी स्पियर आपण कन्सिडर केलेला आहे, तिथपर्यंतच त्याची अट्रॅक्टिव्ह नेचरची जी ॲबिलिटी आहे त्याच्यावरती आपण स्पियर ऑफ इन्फ्लुएन्स कन्सिडर करतो. इट इज अ इमॅजिनरी पार्ट ओनली. Then the definition. The surface tension is defined as force per unit area acting on normally along the line drawn of free surface of that area, that the line. Okay. The surface tension is defined as force per unit area, so that F by L, and surface tension is denoted as T, so that T is equal to F by L. It is in SI unit we in SI unit Newton per meter, and in a CGS unit dyne per centimeter. The dimension of these surface tension is M0 L0 T minus 2. Then the short details. The surface tension is a tendency of liquid surfaces at a rest. The surface tension is the tendency of liquid surfaces at a rest to shrink into the minimum surface area. Possible surface tension is what allows objects with higher density than the water, such as razor blades and the insects are the water sliders, or to float and a water surface without becoming and even partially submerged. We have seen these in the nature. In a rainy season, we have seen these type of examples in road, on the road, and on anywhere where the water are means water are जिथे आपल्याला वॉटर म्हणजे डबक्यात वगैरे पाहायला मिळतात भरपूर ठिकाणी की सबमर्ज झालेले म्हणजे किडे बसलेले असतात, छोटे छोटे इन्सेक्ट्स आर फ्लोट ऑन दी वॉटर surfaces because of the surface tension. There the molecules of water are stretched membrane. तिथे मॉलिक्युल्स काय झालेले असतात, वॉटरचे जे सरफेसला मॉलिक्युल्स आहेत ते काय असतात, स्ट्रेच मेम्ब्रेन फॉर्म झालेले असते त्यांचं तिथे. त्यामुळे छोटे जे इन्सेक्ट्स आहेत किंवा रेझर ब्लेड ही काय असते त्या वॉटरवरती फ्लोट होत असते. अँड interference of the liquid air interference, surface tension results from the greater attraction of the liquid molecules to each other, and due to the cohesive nature that then to the molecules in air due to the adhesive nature. Here the cohesive and adhesive we have seen already. The cohesive means same attraction between the same substance, same molecules in the substance, and adhesive means the which attraction between the two another or the two different substance molecules. Now, next is the angle of contact. It is the main part of these all the things, surface tension and all. Because the angle of contact, we have seen the different types, or the firstly we seen the curve nature of the mercury, curve nature of mercury and kerosene when we take in the जर आपण एका बॉटलमध्ये किंवा एका काचेच्या बिकरमध्ये वॉटर आणि वेगवेगळ्या टाईपचे जसं केरोसिन, मर्क्युरी हे जर घेतलं तर काय होतं, तिथे आपल्याला कर्व नेचर आपल्याला फाइंड आउट करायला म्हणजे पाहायला मिळतं. वी आर ऑब्झर्व दॅट दिस अँड फर्स्ट जी we seen these concave nature in a kerosene or the impurity water. जर वॉटर मध्ये इम्प्युरिटी असेल तर कर्व नेचर पाहायला मिळतं आपल्याला. अँड when the neutral water which have no impurity, then we have seen the flat surface in a glass tube or the glass container. And next one is the mercury. The mercury have the convex nature because of the angle of contact. What is mean by angle of contact? Angle of contact, it is a it defined as the angle between tangent rod to the free surface of the liquid and the surface to surface of the solid at the point of the contact measured within a liquid. The when angle of contact is less than 90 degree, then we have seen the concave nature. And when the angle of contact is equal to 0, is equal to 90 degree, then we have seen the flat nature. And when it is greater than 90 degree, then we have seen the convex nature. And so that we seen the different nature, different curves in the water and mercury. Okay. Next one is the factor affecting the angle of contact. The factors are the mostly the impurities and temperature. The both are the effect on this angle of contact. When the impurities is added, just like a soluble impurities which are the phenol or detergent mixed with water, the water surface tension of water is decreases, and so that the water have good contact with the fabrics, and so that the turf strain are removed, so that we daily use the surf or the other other detergent to wash the cloths and all. And second one, the temperature. When we temperature when effect of temperature, the most liquid as temperature increases, the surface tension is decreases, so that we have the new cotton or new fabrics. Then they suggest that the washed with cold water, because of the it has more surface tension or a high surface tension. Due to that, the water does not mix good contact with that fabric, and so that the fabric doesn't lose their color. But when we use the hot water, then they lose the color, and these fabrics have any type of strain or toughness, tough strain on it. Then that strain also the remove from when we use the hot water or the detergent. दोन्ही जर मिक्स केलं तर आपल्याला खूप खराब झालेला जर कपडा असेल तर तो स्वच्छ करता येतो. म्हणजेच इथे काय आहे की अँगल ऑफ कॉन्टॅक्ट काय होतं तिथलं डिक्रीज होतं, सो दॅट द अँगल ऑफ कॉन्टॅक्ट डिक्रीज झाल्यामुळे तिथे मॉलिक्युल्स, 1 मिनिट, खालच्या स्लाइड मध्ये मी ते दाखवण्याचा प्रयत्न केलेला आहे. ओके, इथे द पार्शियल वेटिंग अँड द नॉन वेटिंग असं हे दाखवलेलं आहे. जेव्हा अँगल ऑफ कॉन्टॅक्ट इज लेस दॅन 90 डिग्री असतो तेव्हा काय, तेव्हा फुल्ली कॉन्टॅक्ट मध्ये येतं वॉटर, आणि सो दॅट द स्ट्रेन आर रिमूव्ह. And we seen in nature the drop have a spherical shape, but why it is a spherical only? Because the angle of contact is greater than 90, so that the drops are spherical in nature. And one more, the that video are not work.
दिसते मॅडम, बोला.
चालू होत नाहीये व्हिडिओ माझा हा.
अच्छा, हा व्हिडिओ चालू, ठीक आहे, स्किप करा, पुढचा घ्या ना.
ठीक आहे,
पुढची स्लाइड घ्या.
हो ठीक आहे. ड्रॉप्स, बिकॉज हे ह्या ज्या व्हिडिओ मध्ये सांगितलेलं आहे की मॉलिक्युल्सची जे बाहेरची जी मॉलिक्युल्सची जी रचना आहे त्या रचनावरून काय सांगितलेलं आहे की इट हॅव मिनिमम सरफेस एरिया. व्हाय ड्रॉप्स आर नॉट इन अ स्क्वेअर or the only for spherical in nature? Why spherical? Only spherical, why? Because of the molecular force or attractive nature in the molecules have the ते एकदम छोट्या कमीत कमी स्पेस मध्ये त्यांना जास्तीत जास्त मॉलिक्युल्सची अरेंजमेंट करायची. मग ते कसं होणार की स्पेरिकल नेचर मध्ये फक्त, आणि बाहेरचे जे मॉलिक्युल्स आहेत ते आतल्या मॉलिक्युल्स अशी न्यूट्रल नेचर असतं त्यांचं, म्हणजे इक्वल अँड अपोजिट फोर्स अप्लाय होतं त्यावरती. त्यामुळे प्रत्येक मॉलिक्युल्स हा काय असतो, न्यूट्रल इन नेचर असतो. सो दॅट द न्यूट्रल नेचर असल्यामुळे जेव्हा ते मॉलिक्युल्स श्रिंक होतात, जेव्हा ते एकमेकांच्या जवळ श्रिंक होतात तेव्हा त्यांचं स्पेरिकल नेचर फॉर्म होतं. असं ह्या व्हिडिओ मध्ये दाखवलेलं खूप छान होतं, पण ते आता चालू होत नाहीये अनफॉर्च्युनेटली. देन द explanation of the drop and the bubbles. When drops having a spherical nature, so that the radius r and the equilibrium on the horizontal surface, the center is O. When the drop is drop have divided into the two parts or two halves, then the equilibrium in the circular section of the equilibrium at a O express the pressure acting upward of the upper hemisphere, so that the force acting on a circular cross section in a upward direction, F is equal to P into A. A is equal to area, so that the P into pi r square. It is the first equation. Next is then this upward force is counterbalanced by the force produced by resultant surface tension forces of the circumference of the circular cross section, which is given as the F is equal to surface tension into length of the circular ring, so that the F is equal to surface tension is equal to the T, so that T into 2 pi r. Comparing the first and second equation, we get P is equal to 2T by R. That formula is observed that the P is directly proportional to the surface tension, means pressure is directly proportional to the surface tension, and inversely proportional to the radius of this circular cross section. Then the sphere of a spherical bubble has two surfaces which are contact with the air, so that there is an excess pressure acting on concave side due to the outward force is given by F is equal to P into 2 pi r square. The inward force of surface tension of a circumference of a circular due to both of the surface, so that the F is equal to we already say that the two free surfaces are there, so that 2 into T, so into 2 pi r. Then we get the P is equal to 4T by r. Same here also, the pressure is directly proportional to the surface tension and inversely proportional to the radius. And the next one is the capillary action. The capillary action we have seen in the nature, and we have seen these water rise up to the topmost of the leaves, and when we topmost of the leaves. And what is the capillary tube? The tube having open ended and which have bore 1 mm is called as capillary tube. The phenomena of rise or fall to a liquid inside a capillary tube when it is dipped in the liquid is called as capillary tube. The here we have the one photograph. When the capillary bore of the tube is decreases, the sudden rise of the water in the tube. We have seen that when the bore of the tube is increases, then the liquid have fall in the tube. Okay, it is a capillary action. The next one is a capillary rise and fall. When we have one container and dip the capillary tube in it, we have the water. Then the capillary action is we have seen the capillary action here. The water have suddenly rise up because of the angle of contact one is part, and here we seen the already have त्याची जी ऑलरेडी हाईट होती त्याच्यापेक्षा जास्त हाईटनी इथे इन्क्रीज झालेलं पाहायला मिळते. ह्या ट्यूब मध्ये वॉटर जे आहे ते सडनली इन्क्रीज झालेलं आपल्याला पाहायला मिळतं. आणि याचं इन्क्रीज होण्याचं कारण म्हणजे अँगल ऑफ कॉन्टॅक्ट. When angle of contact is less than 90 degree, then we have positiveness, means one cos is less than 90 degree असेल तर one येतं ना, so that the suddenly increase the water, and cos theta is greater than 90 degree, then we have the negative sign, so that the mercury have fall म्हणजे त्याची जी आधीची हाईट होती त्याच्यापेक्षा कमी इथे झालेली पाहायला मिळते आपल्याला. h is equal to h is a height in rise or fall in a capillary tube, so that is equal to 2t cos theta by r rho g. The T is equal to tension, surface tension R is a radius of a capillary tube, theta is angle of contact, and rho is a density of the liquid, and G is a gravity due to acceleration due to gravity. Next one is the application of the capillary tube. We have seen a lot of applications in the capillary actions or in a nature. The first one is the color chromatography. We have seen these in a chemistry lab, the color chromatography. And second one is the oil rise up in a wick of lamp, and the ink rises in a pen. They are the daily day-to-day life. We have seen these application of capillarity, and most one, the water rise up to the topmost leaf in the tree uh, because of the capillary action. And thank you so much.
Thank you, madam. You are delivered very nice lecture. Our students and also your college also. Actually, in your college, Manish Deshpande sir, Dr. Manish Deshpande sir is my friend.
Yes,
I
sir.
am working at a assistant professor and HOD Digambar Bindu Mahavidyalaya
Yes.
college. You give the detail theoretically to explain what is the cohesive force, adhesive force, intermolecular force of attractions, and each point you are covered with examples. That is very interesting. Example are very well understood by the students. Also, you take the what is angle of contact, acute, obtuse, and also explain the concave nature, convex nature, and also you give the few daily life examples. Thank you very much, madam. You give your valuable time for us, our students. I hope in this way you will also give to time to take the counterpart classroom another lecture. Thank you,
Yes.
madam. Thank you.
Thank you also to uh, joining me as
Okay, madam.
in your schedule. So that, thank you so much.
Okay, madam. Okay, thank you. Any questions, participant? Participant having any questions? ठीक है, okay, madam.
Thank you so much.